Look around you for a moment. The food you eat, the fuel you burn, the clothes you wear. None of this appears by accident. It all comes from chemical industries. Let's go a little deeper. Chemical industries take raw materials and turn them into useful products on a massive scale. The chemistry is the same as in a lab, but the scale, control, and efficiency are completely different. Here's something even more interesting. One of the most important industrial reactions is the Haber process. It combines nitrogen from the air with hydrogen to make ammonia. Ammonia is the foundation of fertilizers. Without it, modern agriculture couldn't support billions of people. But wait, here's the twist. This reaction doesn't happen easily. It requires high pressure, controlled temperature, and an iron catalyst to make it efficient. Now let's go even deeper. Another key process is the contact process, used to make sulfuric acid. Sulfuric acid isn't just another chemical, it's often called the backbone of industry. It's used in batteries, fertilizers, detergents, and manufacturing. Its production depends on carefully controlled reactions and catalysts. Here's something you see every day: petroleum refining. Crude oil isn't useful by itself. It's separated and processed into fuels, plastics, lubricants, and chemicals through distillation and cracking. Same raw material, different products, pure chemistry at work. Let's connect this to real life. Fuel prices, food production, industrial growth, even national economies depend on chemical industries. Before we wrap up, zoom out for a moment. Chemical industries show how chemistry moves from equations on paper to systems that power the world. They turn theory into infrastructure. And that leads to the final question in this journey. If chemistry keeps evolving, how are new materials at the smallest scale changing technology and the future? That's exactly where we go next.